That's fine. So because of time, I'm going to use my slides from last year and the year before, okay, to go through. Then if I have to write, I will write. Okay. Now, there are also rules of integration. Okay, so the concept of integration is if you differentiate to get an answer. Okay, if you differentiate a question to arrive at an answer, you can integrate that answer and get back that question. Okay, so integration and differentiation work hand in hand. You can't know differentiation or you can't know integration without knowing what differentiation. Now, that is the sign there of integration. When you see this sign, when you see this sign here, you know that you are doing integration. Okay? When you see that sign, you know that you are doing integration. Now, you can integrate y with respect to x, okay? Or you can integrate y with respect to either theta or whatever. Okay? So the sign here means that you are integrating with respect to theta. Okay? This one means that you are integrating with respect to x. So you are integrating y with respect to x here, and you are integrating y with respect to theta. Okay? So that is what integration is all about. Now, integration has its rules as well. Okay? Integration has rules as well. So we have to go through them one after the other. Okay? Now, the basic rules of integration. Like I said, I'm not going to be writing. Okay? I'm just using the slides from previous years. Okay? For the constants, when you are integrating a constant, all right, the constant is that constant multiplied by x. Okay? Also, I'm supposed to tell you this. Your final answer for integration must always have plus c. Why? To show that there might have been a constant there. Remember, we are integrating the question to arrive back at an answer. So we are saying we've differentiated it and it gives us this particular answer. But how do we integrate it back to the question? Okay, so your answer for integration must always have plus c. Everything must always have plus c, except when you are doing definite integrals, which you don't need to write plus c. Okay? It's not a j, it's not a p, it's not an f, it's just like this. Okay. It's not a j, it's just like this. It's like a weird s.
Is it rho?
Not rho. It's just integration sign. Okay? So now, your solution or your answer for all integration problems must always have what? Plus c. Okay? Because if you differentiate c, your differential of c will be what? 0. So to indicate that there might have been a constant in that question, your final answer for integration must always be what? Plus c. All right? So that's it. So now, to integrate a constant, you just multiply that constant by x. And you see, the integration of the constant is what? Kx plus c. Okay? It's kx plus c. Is the constant times x plus c. If you are integrating this one with respect to x, see this one now. See this one here. If you are integrating it with respect to x, you see, this is what the question is. But you are integrating it with respect to x. Therefore, sine theta is a constant. Okay, so your answer there will be what? Sine theta times x plus c. Okay, so the integral of a constant, you can see here, you're integrating 2 with respect to x. The integral of 2 with respect to x is what? 2x plus c. Because if you differentiate 2x, what is your answer? 2. Okay, so the integral of a constant with respect to x or theta is that constant times x or that constant times theta. If you are doing, let us say, if you are doing x dt here, x is a constant now. So it will be what? Xt plus what? C. The integral of constants multiplies what? The variable plus c. Okay? That is the answer of a constant. So if you have the integral of 3 dx, it should be what? 3x plus c. If you have the integral of 5 dx, it should be what? 5x plus c. If you have an integral of 5 theta, okay, it will be 5 the theta. Just imagine if you have 5 the theta, it should be what? 5 theta plus c. That is how to integrate a constant. Okay, that is how to integrate a constant. Okay, that is how to integrate constant. The c is showing that there might have been a constant here, because remember, what are we saying here? Okay, so if I say the integral of 2 dx is 2x plus c. The plus c means that if I differentiate this, I will get just what? 2. Okay. The plus c means that there might have been a constant there to arrive at that integration problem. Okay, because the differential of a constant is what? 0. The differential of a constant is 0. That's why it's called a what? General solution. So every time you integrate, like I'm saying it again, every time you integrate, you must put plus. Okay? Every time you integrate, okay? When you have an exponent or the powers of x, or when you say x raised to power n, you understand? How do you integrate that one? Okay? If you look at this side, I'm here now on this side. If you look at this side, the integral of x raised to power n is x raised to power n plus 1 over what? N plus 1 plus c.
Yes.
You understand? So if you have x squared, x raised to power 3. Now look at this t's and c's here. Okay? N must not be equals to what? Negative 1. Okay? Your n must not be equals to negative 1. If your n is equals to negative 1, you can't use this formula. Okay? You can't use this formula. Your n must not be equals to what? Negative 1. If your n is equals to negative 1, you can't use this formula. So anything, if you have, let us say an example, if you have to integrate 1 over x squared with respect to the x, this is the same thing as the integral of x raised to power minus 2 dx. You can still use that formula. Okay? You can still use that formula. This is what? What is this? You just say is what? X raised to power minus 2 plus 1 over what? Minus 2 plus 1 plus. It must not be equal to negative 1. Okay? So if negative 2, if it's negative 3, you simplify it first, then apply that formula. I'm coming to that. Okay. So this is what? X raised to power minus 1 over what? Minus 1 plus c, which is equals to minus 1 over x. That's fine. So that is how integration works for powers. Okay? That is T's and C's slash, okay? So you see, these are examples as well. If you have to integrate 1 over x squared, we just did that one. Okay? If you have to integrate 3x cubed, you can remove out the 3. The coefficient, you don't bother about that. Okay? It multiplies the final answer. You remove out the 3, then just integrate the what? X cubed. Okay? to just integrate the x with 3 plus 1 over what? 3 plus 1. Then you see what you have here. That will be your final answer. All right. So that is how to solve integration problems. Okay. When you have powers. Okay, when you have powers of integration of raised to power x raised to power something. Is that fine? Now, what if you have your n minus 1 now? What if your n is equals to minus 1? What is x raised to power minus 1? X raised to power minus 1 is what? 1 over x. You understand? X raised to power minus 1 is 1 over x, isn't it? It's the same thing as 1 over x. What do you differentiate to get 1 over x? The differential of ln x is what? 1 over x. So the integral of 1 over x is what? Ln x. So the integral of this one, x raised to power minus 1, is just ln x. Okay, the integral of x raised to power minus 1 is the same thing as 1 over x. And the differential of ln x is what? 1 over x. So therefore, the integral of 1 over x is what? Ln x. Remember I said they are opposites. Okay, so they are opposites. So if you see an example here, look at this one. Okay, you don't need to simplify it. You can't use that minus 1 plus 1. You don't need to do that one. Okay, you just know that when you have 1 over x, the integral of this is what? Ln x plus c. Okay, the integral of it is ln x plus c. Sorry guys, I am going fast because it's supposed to be the last class today. Okay, but I'm still trying to see if I can create a class tomorrow. I said that already at the beginning of the class. Okay, so now that is how I can't go back. I can only go forward. Okay, don't worry. The recording, I'm recording. Okay, that's fine. That is how you integrate x raised to power minus 1. The integral of that is what? Ln x. Good. What if you have an exponent, a raised to power x? Is that fine? How do you integrate a to the power of x? Okay. How do you integrate a to the power of x? Remember, to differentiate a to the power of x is what? A to the power of x times ln a. Okay. So to integrate a raised to power x, okay, it's what? A raised to power x over what? Ln a. To integrate a raised to power x, your a can be any number. Okay, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6, -1, -2, -3. It can be anything. Okay, so when you are integrating a raised to power x, the integral of a raised to power x is what? A raised to power x divided by ln x, a plus what? C. Okay, a raised to power x divided by ln x, ln a, sorry, plus C. Good. So if I ask you to integrate a raised to power x, okay, with respect to what? Dx. Okay, this is what? 2 to the power of x over what? Ln 2 plus c. 2 to the power of x over ln 2 plus c. That is the rule. So that's why I'm saying I said what? A to the power of x dx is equals to a to the power of x over what? Ln a plus c. Okay? So that's how to integrate that one. Okay? That is how to integrate. Fine. So y is and n is what? K is a constant, yes. Okay, good. So that is how to integrate it. So C is the constant. C is the constant. Okay. A is any base ranging from 1 to whatever number. Okay. Are we together? So that is what we're doing. So if you have the integral of a to the power of kx now, what if you have a coefficient there in front of that x? Okay, so this is what a to the power of kx then over k times ln a plus. You understand? Okay, so a to the power of kx over what? K times ln a plus c. So if I'm supposed to integrate, for example, 2 to the power of 3x, 2 to the power of 3x, you don't need to manipulate this. Just say that this is equals to 2 to the power of 3x, 3 times what? Ln 2 plus c. Understand? 2 to the power of 3x times what? Divided by 3 times ln 2 plus c. That is how to integrate this. Remember I said I wanted to finish this today, and I told you that if people don't ask me questions, I can finish it. See the questions. You understand? Okay. It's fine. I have to look for a way to come up with another question. All right. So the next one, what number am I now? Okay. Okay. What number am I now? Yeah. How many rules have I written down now? 4. No, I did constants, number 1. Powers, then I did x raised when n is -1. Okay. Then I did this one. So it's number 5. Okay. Guys, if you press the raise hand button, it won't change anything. I have to rush this. Okay. Okay. You can watch the recording. The more I'm talking to you guys, the time I'm wasting. Okay. You can watch the recording. All right. So number 5 now, right? Okay. The integral of e to the power of x dx. Now I'm writing now is what? The differential of e to the power of x is still e to the power of x. So therefore, the integral of e to the power of x as well, it will be e to the power of x plus c. Okay. It will be e to the power of x plus c. Okay. Then sort out Mr. Sort out Joshua there. He's asking a question. Okay. So also, when you have e to the power of what? Kx, right? Just imagine there was a k there, or there's a coefficient there, e to the power of kx. If you have that, this is the same thing as what? E to the power of kx divided by k plus c. Okay? These are the basic rules of what? Integration. Okay? So if you have an example, let us say if I give you e to the power of 2x, yes. How do you integrate this? You say what? E to the power of 2x divided by 2 plus. Okay? E to the power of 2x divided by 2. Okay? So that is how to integrate it. What if I have this question here? If I have the integral of 1 over e to the power of 2x, what do you do here? You simplify the question first, okay? And say that this is the integral of e to the power of what? Minus 2x dx. Okay, then apply your integration. How do you integrate this? This is what? E to the power of what? 2x over what? Minus 2 plus c. Okay, you simplify it first by what? Bringing it up. Then apply your integration. Now, look at this question. What if you have the 1 over 2e to the power of 2x dx? That's fine. What do? You can't bring that 2 up because it's the coefficient. You only bring out the function. Or you can what? Remove the 1 over 2 as a constant. What do I mean? 1 over 2, then the integral of what? 1 over e 2x dx. Okay, this one you simplify. So this is 1 over 2 times the integral of e to the power of negative 2x dx. Okay, then you integrate this. If you integrate this, you have what? 1 over 2 times e to the power of negative 2x over negative 2 plus 6. Okay, then that becomes 1 over 4, negative 1 over 4, negative 1 over 4, e to the power of 2x, negative 2x plus c. And that is your final answer. Okay, so I'm just indicating all areas where questions can be asked. Because you see, the same principle as we did differentiation, they will line up the answer question like that. And they say integrate everything individually. Okay? That's how they will do it. So that's why I'm taking it step by step. Okay? I was going to cancel that class tomorrow, but I can't now. I have to come back tomorrow again. It's fine. Remember, I have load shedding at home, so I don't know when time. Okay. But it's fine. I'll make a plan. All right. So now, that is for exponentials and all those ones. So what number am I now? 6.
6.
Yeah, 6.
Well, actually, 7.
Is it 7?
6.
Okay. 6.
6.
I've been doing too many examples. Don't worry. I think I'm a 6. Okay. So now let's see how to integrate the tricks. Okay. Let's see how to integrate the tricks now. Let's start with sine. The differential of what? Cos is what? Negative sine. So the integral of sine should be what? Negative what? Cos. Okay, because remember, the differential of cos is what? Negative sine. Okay, so if you flip a positive sign, okay, and you're integrating it, you will get what? A negative cos. So the integral of what? Sine x dx is equals to negative cos x plus. Okay, the integral of sine is negative cos. Okay, because the differential of cos is what? Negative sine. Understand? So if I'm differentiating this, right, I will have what? Negative what? Sine x.
So be positive.
Positive. So the differential of this will give this. That's why the integral of what? Negative of sine is what? Negative cos. So what if I have sine? Honestly, with the speed I wanted to use today, I can't do it anymore. Guys, I've just ruined my day. Okay, so if you integrate this now, what do you have? The integral of this will be what? Negative cos ax over a plus c. Okay, it will be negative cos ax over a plus c. So if I'm supposed to integrate, let us say I'm supposed to integrate what? Sine 3x. Okay, I'm supposed to integrate sine 3x dx. How do I integrate this one? It's what? Negative cos 3x over 3 plus c. But that is how to integrate what? Sine. Now, if you look at your formula sheet, all these rules I'm saying are not there. I'm taking it step by step. Okay. That's why I'm taking it step by step. But when you get to N5, they give you all the rules. But for N6, you have to know it by.
So they give it to you in part, but in N6 they don't give it.
But you see, what you can do is that if you look at your formula sheet, all you just have to do is the formula sheet is the differentiation that is there, right? But there's a bit of integration. All you just do is take it back.
Oh,
You understand? You understand? And then you will get your answer. All right, so now let's move on. I'm in which number now? Number 7. Okay. So the integral of cos now. How do you integrate cos? The differential of cos is what? The differential of sine is what? Cos. Okay, so the integral of cos will be what? Sine. Okay, so you see, the differential of cos x is negative sine x. Okay, then the integral of what? Cos x is positive what? Sine x. So it's like an opposite. You understand? Okay, don't confuse the two. Are we together? So what will this one be? It will be what? Sine x plus c. Okay. What if you have a coefficient in front of the x? So if you have cos ax dx, it will be what? Sine ax over a plus c. You understand? So that is how to what? Apply those rules. Are we together? Okay. So that is how to apply those rules. So if I have the integral, look at this. If I have the integral of 1 over sec 3x dx, what do I have to do first? I have to use my identity to simplify the question first. Okay? We know 1 over sec is what? Cos. So it's the same thing as the integral of what? Cos 3x dx. Is that fine? How do you integrate this? This is what? Sine what? 3x over 3 plus c. Okay? Because if you differentiate this one here, you should be able to arrive at just what? Cos ax. Okay? Because remember, if you differentiate c is a constant, right? The differential of c will be what? 0. Okay? So you can't know integration if you don't know what? Differentiation.
but integration cannot be differentiation.
It can. Differentiation first, then integration. You can't skip differentiation
I know,
to know. Yeah.
Like let's say they give you the sine ax over a, and like you like how do you differentiate it? If you remember the rule, you can just change it to as ax.
Okay. All right. So now let's go to tan. Okay. How do you integrate tan? It's what? Ln sine x. Okay. It's ln sine x plus c. The integral of tan is ln sine x plus c. Okay. So if you have, that's a sine. Oh, it's a sec. Sorry. It's ln sec. Okay. So if you have the integral of what? Tan ax, what will it be? It will be what? Ln sec ax over what? A plus c. Is that fine? So that is how to integrate what? Tan. Now, what number am I now?
9. So
9. Good. What if I have the integral of sec squared x? How do I integrate sec squared x? The differential of tan is what? Sec squared. Okay, so if I'm integrating sec squared, my final answer should be what? Tan. Okay, the integral of sec squared is what? Tan x plus c. Understand? Sec squared. Because you see, let me open my formula sheet here. Look at this. See what it says here. You see now in this one, they only gave you what? These few rules. They only gave you these few of them. But see this one. Sec. Because here, if I differentiate tan, I get what? Sec squared. So if I'm going back, what am I doing? I'm doing what? Integration. Okay. If I'm moving from left to right, I'm doing what? Differentiation. If I'm going from right to left, I'm doing what? Integration. You understand? Okay, so you can look at it like that. Okay, especially for the what? Trig ones. You understand? Especially for the trig ones. But because I don't want you guys to get confused, that's why I said these rules. Constant practice altogether. Constant practice helps. You might not even need the formula sheet. Okay, if you know how to apply. Okay, because I don't have any formula sheet in front of me, and I'm showing you the rules. Okay, so the constant practice helps. So now let's do if you have a coefficient here. What happens when you have the integral of what? Sec squared ax dx. What is the integral of sec squared ax? It's what? Tan ax over a. Okay, that is how to integrate that. What rule am I now? 10. Good. Let's move to this one. Okay, so what if you are supposed to integrate what? Cosec squared. How do you integrate cosec squared? Okay, the differential of cot is negative cosec squared. So the integral of cosec squared is what? Negative cot x plus. You understand? It's negative cot x plus. Please, your final answer always have C. Look at this. This is how the question will come out, as long as this. Okay? It's just the same thing as we did in differentiation.
So it's not classic each of them.
Not for each of them, for everything, just one C. Okay? Not for each of them. For everything, just one C. Okay? For everything, just put a plus. All together. So that is the last one that is also very vital. How many am I now? I'm supposed to give you, is it 15? No. 11 or 12. I think it's 12. I just left it to sec x and x. Okay, what's the integral of this one? This is what? Sec x plus c. Then, the integral of what? The last one is cosec x cot x. The integral of this one is negative cosec x plus. So what if it has a coefficient? You just divide it by that coefficient. Is that fine? What do I mean? If you have the cosec 2x, okay, cosec 2x times what? Times cot 2x dx. This is equals to what? Negative cosec 2x over 2 plus. Okay, so those are the basic rules. Let's go into questions now. Look at this question here. 5.2. Okay, look at this question, 5.2. Now, like in the first one, the differentiation one, there are some cases we might need to what? Simplify first. Okay, there are some situations that we might need to simplify first. What are the situations here? Number one, 4 pi 3 over x, 3 to the power of x, right? It's fine. You can integrate that one. You don't need to bring it.
No, I'm talking to myself.
Okay, that's one. You can integrate it using the. Is it?
Okay.
No. The first one was what? Constant. The second one was what? Powers. The third one was what?
So
Minus
A.
A. The one of A. Yeah. The one of A. The one of Kiera was. Yeah. That's number what? Number what?
No, I don't know the numbers.
No, I think number 4. Number 4. You can integrate that one using rule number 4. Okay? Using rule number 4, you can integrate. If you are writing the numbers I was writing, okay? Using rule number 4, you can integrate that one. Now, we have 5 pi over x. How do you integrate that one? You don't need to bring the x up. Remember, if you bring that x up, what will be the exponent? Minus 1. Okay? So what you need to do is you integrate 1 over x. What is the integrator of 1 over x? Then, tan x sec x. That is number what? 11. Just wrote that one down. The negative cosec squared. That is rule number what? 10. You just wrote it down. The only one you need to simplify is this one. 1 over e raised to power 3x. By bringing it what? Up. Yes. The next one is fine as well. You can integrate that one using the same rule number 4. P is rule number what? 1. Because P is a what? Constant. Then you write your final answer. Plus C. How many marks is it? It's what? 7 marks. Okay? So that is how to integrate. So because of time, I have to do that. I thought I would be able to finish it, but you guys you didn't work with me. The questions that were flying when I started was too much. Okay? So what happens is that tomorrow I have to create another class. So I will check my load trading schedule. Then just be aware. Just check your portal tomorrow. That's fine. I can't say the time specifically. I don't know the load shedding I'm on right now. I don't know if it's load season 5 or season 4 or season 1. I don't know which load shedding I'm on. So what we'll do is that I'll create a 2-hour class tomorrow. Okay. For those of us that are not busy, you can attend. But definitely.
But just not sure.
What time? Yeah.
So should we check from 8?
Check from 8. Okay. Check from 8. Then, if to be safe, I think 9 is safe, isn't it? Because there's always that load shedding. I can do it at 9. Okay. So we'll do that tomorrow. I will make it 2 hours so that we have time for questions and